The Interstate Road 163 in central Brazil, cutting through what is still the biggest rainforest in the world. Along the sandy road, the story is continually repeated. Loggers clear the pristine forest, then after a few years of cattle farming or crop cultivation, the soil is depleted. Farmer Claudio Solecci in Sinop is cultivating crops on what was rainforest 30 years ago.
Here you
see the typical soil of our region. It's very poor in organic material.
The problem starts with soil degradation, which means low levels of nitrates and phosphates, and furthermore, high acidity. So, only 3 decades after the rainforest is cleared, the soil is depleted. So, how to find a solution? A German scientific team with project coordination from the Georg August University in Göttingen develops sustainable strategies to decrease greenhouse gas emissions and increase soil carbon, a project called Carbiocial.
Carbiocial is working on soil science. We try to enrich or to enhance the soils in the tropical region of Brazil to fix as much carbon in the environment and the landscape as possible.
Carbon dioxide and other greenhouse gas emissions increase when the rainforest is cleared. To mitigate climate change, the goal should be to store as much carbon as possible in soil and plants. So sustainable agriculture and forestry might serve 2 goals at a time.
If we store much more carbon in the soil, it's not only good for the global climate, but it's also good for the farmer, so his income will be better.
The scientists started with analyzing the soil and the ecosystem services, and they explain their project to the farmers.
What are the objectives of this project on this farm?
Another objective in the interviews is to identify typical socio-economic patterns. Finally, practical recommendations are at hand. For instance,
we need a pasture with a lot of vegetation above the soil, and that means woody legumes where the cattle can eat the leaves, but the same plant is also good for the soils which produce nodules to enrich the soil with nitrogen. And this is the idea that we don't have a monoculture, but a pasture with a lot of bushes and trees in it.
Other recommendations focus on storing as much carbon as possible. For instance, in the so-called APPs, areas of permanent preservation, no agriculture is permitted in a 50-meter wide zone along rivers.
This is an APP, one of the best APPs on our land. We try to preserve the pristine landscape along the rivers because we depend on these waters for our cattle. In future, we would also like to use the water for irrigation. So we know that APPs are a core element of water protection.
The scientific team will collect data and run simulations addressed to stakeholders and farmers. If they type in their land use strategy and farm data, they will immediately see regional and even global consequences.
With this decision support system, they can see what are the consequences in the future, what will happen when every farmer will do that. Then there will be a direct effect on the climate, on the economic situation, on the social situation in the village.
The farmer, Manuel Machado, was a little skeptical at first, but he has finally changed his mind.
I think your project is very helpful. When you complete your analysis and deliver its results to us, it gives us a much better idea of how to improve our work.
These farmers are pioneers in a historic situation, the very beginning of agriculture in this region, with the chance for a sustainable land management under scientific consultation. And from the scientific point of view, this project could be a blueprint for similar regions all over the world.